Modern nuclear weapons embody the pinnacle of destructive power achieved through human technological innovation. Their capabilities, consequences, and implications extend far beyond their original conception, presenting unprecedented challenges to global security and human survival. This paper examines the contemporary magnitude of nuclear weaponry, focusing on its enhanced destructive capacity, ecological and socio-political ramifications, advancements in technological precision, and ethical dilemmas within the framework of modern geopolitics. The development and deployment of nuclear weapons represent a transformative milestone in the history of warfare and international relations. Originally conceived during World War II, these weapons have undergone profound technological and strategic advancements, far surpassing the capabilities of their early predecessors. This study seeks to elucidate the true scale of modern nuclear weapons, encompassing their destructive potential, the environmental and geopolitical consequences of their use, and the ethical considerations inherent in their continued existence. The destructive yield of modern nuclear warheads far exceeds that of the atomic bombs utilized in Hiroshima and Nagasaki. For instance, the Tsar Bomba, detonated by the Soviet Union in 1961, remains the most powerful nuclear device ever tested, with an explosive yield of 50 megatons of TNT, approximately 3,000 times the power of the Hiroshima bomb. Contemporary strategic warheads, such as those deployed on intercontinental ballistic missiles, ICBMs, typically range from 100 kilotons to several megatons in yield, rendering them capable of obliterating entire urban centers and inflicting catastrophic loss of life. Moreover, the immediate effects of a nuclear detonation, intense heat, overpressure shockwaves, and ionizing radiation, are compounded by secondary phenomena such as fires and infrastructural collapse. These weapons inflict not only acute destruction, but also long-term environmental and health impacts, including radioactive contamination and increased cancer rates among affected populations. The detonation of nuclear weapons on a large scale would precipitate far-reaching environmental consequences. Among the most dire scenarios is the concept of nuclear winter, wherein massive quantities of soot and particulate matter released into the atmosphere block sunlight, resulting in significant global cooling. This phenomenon could disrupt agricultural production, leading to widespread famine and socioeconomic collapse. Radiological contamination poses an additional long-term threat to ecosystems and human populations. The persistence of radioactive isotopes in soil, water, and air disrupts ecological balance and increases the incidence of genetic mutations in both flora and fauna. These consequences underscore the existential risk posed by nuclear weapons to planetary stability and biodiversity. Modern nuclear weapons have evolved in both precision and deployment capabilities. The advent of multiple independently targetable re-entry vehicles, MIRVs, has enabled single delivery systems to target multiple locations simultaneously, thereby increasing the efficiency and strategic value of each missile. Additionally, tactical nuclear weapons, designed for limited use on the battlefield, have emerged as a contentious element in military strategy, lowering the threshold for nuclear engagement and escalating the risk of conflict escalation. Advanced delivery platforms, including submarine-launched ballistic missiles, SLBMs, and hypersonic glide vehicles, further complicate the strategic landscape. These technologies enhance the survivability and rapid deployment of nuclear arsenals, rendering traditional deterrence models increasingly precarious. The continued existence and proliferation of nuclear weapons raise profound ethical and geopolitical dilemmas. While nuclear deterrence has arguably prevented large-scale wars through the principle of mutually assured destruction, MAD, it perpetuates a global security paradox wherein the possession of such weapons is both a stabilizing and destabilizing force. Furthermore, the The potential for nuclear proliferation among non-state actors and rogue states exacerbates the risks associated with these weapons. International treaties, such as the Treaty on the Non-Proliferation of Nuclear Weapons (NPT), seek to mitigate these risks by curbing the spread of nuclear capabilities and promoting disarmament. However, the efficacy of these agreements is hindered by geopolitical rivalries and asymmetries in enforcement. Modern nuclear weapons encapsulate an unparalleled magnitude of destructive capability and global risk. Their potential to inflict immediate and long-term devastation necessitates rigorous international oversight and cooperative efforts toward disarmament. As technological advancements continue to redefine the strategic calculus of nuclear warfare, the ethical and ecological imperatives of reducing nuclear stockpiles become increasingly urgent. Addressing these challenges requires a concerted commitment from the global community to safeguard humanity and the planet from the catastrophic consequences of nuclear conflict. The aftermath. What would happen to Earth? The detonation of multiple modern nuclear weapons would not only devastate human populations, but would also irreversibly alter Earth's environment, ecosystems, and long-term habitability. The consequences of such an event extend far beyond immediate destruction, threatening the intricate balance that sustains life on the planet. Below are the key outcomes of a large-scale nuclear conflict and its impact on Earth. A large-scale nuclear exchange would unleash extraordinary amounts of energy, heat, and radiation. The initial explosions would generate firestorms. The detonation of multiple nuclear warheads over urban centers would create massive firestorms, consuming oxygen, destroying infrastructure, and incinerating all organic matter within their range. Release radioactive fallout. Intense radiation would spread through the atmosphere, carried by winds to regions far from the initial detonation sites. Fallout would contaminate soil, water, and air, rendering large swathes of the Earth uninhabitable. Destroy the ozone layer. The heat and chemicals from nuclear explosions would deplete the ozone layer, exposing Earth to dangerous levels of ultraviolet radiation, leading to increased cancer rates and environmental degradation. One of the most devastating consequences would be nuclear winter, a phenomenon caused by the injection of soot and debris into the stratosphere. This would block sunlight. Particulates in the atmosphere would reduce sunlight reaching the Earth's surface, causing global temperatures to drop dramatically. Trigger a mini ice age. A prolonged cooling period would disrupt weather patterns, shorten growing seasons, and lead to widespread crop failures. Cause massive ecological collapse. With plants unable to photosynthesize effectively, ecosystems reliant on vegetation would begin to collapse, leading to mass extinctions across the food chain. The scale of destruction from nuclear detonations would severely impact Earth's biodiversity. Mass extinctions, radioactive contamination, combined with habitat destruction and climate shifts, would push countless species to extinction, including many keystone species vital to ecosystem stability. Ocean acidification. Fallout and chemical byproducts could alter ocean chemistry, harming marine life and disrupting global carbon cycles. Erosion of natural habitats. Forests, wetlands, and other critical ecosystems would be decimated by fires, radiation, and secondary environmental effects. While humanity is highly adaptable, the scale of disruption caused by a nuclear conflict would challenge even the most resilient societies. Global famine. The collapse of agriculture due to nuclear winter would leave billions without access to food. Starvation and resource wars would follow. Economic collapse. The destruction of industrial centers, infrastructure, and trade networks would lead to an irreversible economic breakdown. Population decline. Immediate casualties from blasts, combined with long-term radiation sickness, genetic mutations, and famine, would decimate the global population. The Earth's recovery from a large-scale nuclear conflict would be slow and uncertain. Key challenges include decades of radiation contamination. Affected regions would remain uninhabitable for decades, or even centuries, due to persistent radioactive isotopes. Altered ecosystems. Surviving ecosystems would adapt, but the resulting biodiversity would be vastly diminished compared to pre-conflict levels. Human adaptation. Survivors would need to contend with genetic mutations, reduced access to resources, and new environmental conditions. The rebuilding of civilization would depend on cooperation, resource management, and technological ingenuity. Ultimately, the Earth itself would persist, but its ability to sustain life, as we know it, would be profoundly compromised. The planet would enter a new geological epoch defined by radioactive contamination, reduced biodiversity, and altered climatic conditions. While the natural world has shown remarkable resilience in the face of past mass extinctions, the anthropogenic nature of a nuclear apocalypse means that recovery would depend on humanity's capacity to mitigate its own self-inflicted damage. What will happen to animals in the aftermath of a nuclear war? A large-scale nuclear war would have catastrophic effects on the animal kingdom, both immediate and long-term. Radiation, climate changes, habitat destruction, and food scarcity would impact animals worldwide, leading to mass extinctions and severe disruptions in biodiversity. Below is an analysis of the potential consequences for animals in such a scenario. Explosions and firestorms. Animals within the blast zones would perish instantly due to the shockwave, intense heat, and subsequent fires. Toxic emissions. The release of toxic chemicals and gases would poison animals even far from the detonation sites. Pressure and sound waves. The force of the shock waves would damage internal organs in animals, particularly larger mammals. Acute radiation sickness. Animals exposed to radiation would suffer from internal bleeding, tissue damage, and infections, leading to death within weeks. Genetic mutations. Long-term radiation exposure would cause genetic mutations in surviving animals, resulting in malformed offspring, reduced fertility, and population declines. Immune system weakness. Radiation would weaken animals' immune systems, leaving them more vulnerable to diseases. A loss of natural habitats. Massive fires, radioactive fallout, and climate shifts would destroy forests, wetlands, and water bodies, depriving animals of shelter and food. Disruption of food chains. The disappearance of plants due to radiation and nuclear winter would starve herbivores, which in turn would affect predators at the top of the food chain. Collapse of ecosystems. Without pollinators like bees and other key species, ecosystems would fail to function, triggering further extinctions. Nuclear winter. The soot and debris from nuclear explosions would block sunlight, dramatically lowering global temperatures. Animals accustomed to warm climates would struggle to survive the sudden cold. Acid rain. Toxic substances in the atmosphere would lead to acid rain, contaminating water sources and soil, and harming aquatic and terrestrial species alike. Food scarcity. Disrupted ecosystems and agricultural collapse would leave surviving animals with little to no food sources. History has shown that mass extinctions can result from global catastrophes like asteroid impacts or volcanic eruptions. A nuclear war could cause similar outcomes. An extinction of large animals. Large mammals like elephants, lions, and bears would be particularly vulnerable to food shortages and habitat destruction. Survival of small species. Small, adaptable animals like rodents and insects would have a higher chance of survival, though their populations would also decline significantly. Marine life extinctions. Radiation and ocean acidification would devastate coral reefs and phytoplankton, the foundation of marine ecosystems, leading to the collapse of fish populations and other marine species. In the harsh conditions following a nuclear war, surviving animals may adapt over time. Radiation resistance. Species with natural resilience to radiation, such as cockroaches and tardigrades, could thrive in the altered environment. Evolutionary changes. Over thousands or millions of years, surviving species could evolve new traits to adapt to the changed conditions, potentially leading to entirely new ecosystems. A nuclear war would not only devastate human civilization, but also irreparably harm the animal kingdom. The immediate effects of radiation, climate shifts, and habitat destruction would result in mass extinctions and long-lasting genetic consequences for surviving species. While nature has a remarkable ability to recover, the process would take millions of years, leaving Earth's ecosystems vastly diminished. This potential catastrophe underscores the urgent need to prevent such a scenario and protect the planet's fragile web of life.